So number 4, there's a lot of this that looks quite good. You'll see that in these steps here there's no math errors. But the fundamental problem on this one is right here. What this is saying is if we have two numbers that multiply to 4, the student said that, well, one of the numbers basically has to equal 4, which is not true. For example, 2 times 2 would also equal 4. So just because two numbers multiply to be a number, you cannot assume that one of them is in fact the number, except in the case when it was 0. I think what this student was thinking was probably visualizing something like this: x minus 3 times x minus 1 equals 0. In that case, because it's 0, you would in fact be able to do x minus 3 equals 0 or x minus 1 equals 0, because we call that the zero product property, the ZPP. If you do have numbers that multiply to 0, we know that that means that one of them must be 0, which is one of the key ideas behind factoring. So this was the key mistake in this problem. If you were going to solve this one for real, you'd actually multiply this out to get x squared minus 3x minus x plus 3 equals 4. I'm not going to actually finish solving it out, but you'd bring this 4 over here, minus 1 equals 0, and that's the equation you would actually solve to answer this question. But the idea, the reason I wrote this problem here was I was trying to make sure that you understood the zero product property here. And just because you see two numbers multiplied together, don't assume that they equal the number that equals that number unless it's 0. These are already in factored form, so we can leverage that zero product property. So we have two numbers that multiply to 0, so this is a very straightforward one to solve. The first factor equals 0, or that second factor, second factor equals 0, and therefore we can solve this, add 1 to both sides, we get x equals 1, or x, and then add 4 to both sides here, x equals 4. Some people like to just note that those solutions are the opposites of the numbers shown there, but I like to go through the formal thing here, because that way you just don't forget and don't get messed up. On B, same thing here. We can set 5x equal to 0, or x minus 4 equal to 0. Divide both sides by 5 here, we get x equals 0, or we add 4 to both sides here, we get x equals 4. So those are the two solutions to B. So these are in square root form. So here we always have that x term inside of a square. You could always multiply things out and use other techniques, but whenever you see it this way, it's often easier just to take square roots of both sides. So here the goal is to get that x squared expression by itself. So I'm going to add 9 to both sides. X squared equals 9. And I can go ahead and take the square root of both sides, which gives square root of x squared is just x. When I'm solving equations, I have to remember to take plus or minus here. So x is plus or minus 3. So x equals negative 3, or x equals 3. If I plug both those back in, you can see that they'll work, because negative 3 squared is positive 9. Positive 9 minus 9 is 0. Same thing with positive 3. Here, I can, this expression with the x squared is already isolated by itself, so I can go ahead and just take the square root. Square root, and then plus or minus the square root of 49, because I take the square root of both sides. Square root of x minus 2 squared is simply x minus 2, and square root of 49 is 7. So I'm going to add 2 to both sides here. So x equals at 2 plus or minus 7. So that will give me x equals 2 plus 7, which equals 9. Or x equals 2 minus 7, which is negative 5. So those are the two solutions. 9, -5. Here, again, going to get that x squared by itself. X squared equals -100. Normally we would be unhappy with this problem because we're going to take square roots of negative numbers, but now that we know complex numbers, we can actually solve this. So if I go ahead and take the square root of both sides, and again take plus or minus, -100, square root of x squared is just x, plus or minus, and now I can rewrite this from what we learned in Unit 3. Square root of 100 times the square root of -1. Square root of 100 is just 10. That by definition is I. So x equals plus or minus 10i. So x is 10i, or x equals -10i. Last one here, and our goal is to get that little expression here by itself. So the first thing I'll do is add 18 to both sides. 2x plus 1 squared equals 18. Divide both sides here by 2 so I can keep getting that expression by itself. X plus 1 squared equals 9. Now I'm going to spot to take the square root of both sides. Equals plus or minus the square root of 9. Again, x squared plus 1 squared. Square root of x plus 1 squared is just x plus 1. Equals plus or minus 3. X equals, subtract 1 from both sides, -1 plus or minus 3. X equals -1 minus 3. Or x equals -1 plus 3. X equals -4. Or x equals 2. For 7 here, this is just brute force application of the quadratic formula. I'm going to go ahead and just do one of them. I'll do this first one here. I think that one turns out to be slightly more complex. So the first goal is to make sure it's written in ax plus bx plus c, ax squared plus bx plus c form, which it is. And I'm just going to identify those coefficients. So we know that a equals 1, b equals -2, c equals 3. And then we're just write the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And then it's just quote unquote plug and chug from here. So -b is negative and -2 plus or minus -2 squared minus 4. A is 1, C is 3, all over 2 times A, which is 1. So -2 times negative of -2 is just +2. Underneath the radical here we have 4. -2 squared is 4 minus 12. So we can see we're going to have solutions that have I in here. 2 times 1 is 2. 2 plus or minus square root of -8 all over 2. Now we have to deal with that -8. We know that that's the same thing as the square root of 8i. By just taking out the negative sign there. And then the square root of 8 is 2 square roots of 2, still times I, all over 2. And then we can just distribute this 2 here. 2 divided by 2 plus or minus 2 square roots of 2i all over 2. Which is going to give us 1 plus or minus root 2i. And I'm going to rewrite that to make sure that it's clear that the I is outside of the root 2. And that would be the answer. B is the same formula. Maybe just make sure you got the right coefficients. Here we'd use A equals 2. That's the number in front. B is 8. and c equals 8. And then you would go from there.